Hi. So far we learned about what is hypothesis testing and the critical value approach to hypothesis testing. Here in this lecture, we learn about another approach which is called p-value approach for hypothesis testing. Now, what is p-value? Well, in hypothesis testing, p-value is the probability of getting sample data at least as inconsistent with the null hypothesis as the sample data actually obtained. We use the letter P to denote the p-value. In other words, it is a measure of the strength of the evidence against null hypothesis. Uh, Also, probability of getting the observed value of the test statistic if S naught is true is p-value. Now, to understand this concept clearly, let's say for a variable with the density curve, the percentage of all possible observation of the variable that lie within any specific range equals, or at least approximately, the corresponding area under the density curve expressed as a percentage. Now, let me show you the picture. Okay, so here you will have a fixed value in actual problems. You'll have a fixed z value. Now area to the left of that value is the v value. So percentage of all possible observation of the variable that lie to the left of this c equals to this area expressed as a percentage. So basically p value is just area to the left of the given z values. Similarly, in this another example, for the area to the right of D, the percentage of all possible observation of the variables that lie to the right of D equals this area. And here, if you have a 2G values, then the percentage of all possible observation of the variable that lie between A and B equals to this dotted area. Now, the procedure for deciding whether you reject null hypothesis or fail to reject null hypothesis is pretty similar with the critical value approach. Now, the only difference thing is, since we are talking about p-value, you can also say probability value. So if p-value is less than or equals to the specified significance level, we reject the null hypothesis. Otherwise, we do not reject the null hypothesis. Now, in every problem, there will be a specific significance level alpha. So if p-value is less than or equals to alpha, we'll reject null hypothesis. Otherwise, we do not reject null hypothesis. Now, the way the actual problem uh, work is this way. So for example, if you are talking about two-tailed test, then you'll get a two critical value, right? Let's say z naught and negative z naught. Now p-value is you need to find the area of this region and this region. And for left tail test, you'll have only one region to the left of that critical value, and then for right tail test, you'll have only one region to the right. So we'll find these areas, and if this p-value is less than or equals to the significance level alpha, then we reject null hypothesis. Otherwise, we fail to reject null hypothesis. So the p-value approach of hypothesis testing is just like critical value approach. We first state the null and alternative hypothesis, decide on the significance level, normally it's given, and compute the value of test statistic, and we'll determine the p-value. If p-value is less than or equals to alpha, we reject null hypothesis. Otherwise, we do not reject as not null hypothesis. And then we interpret the result. So for example, if p is indeed less than or equals to alpha, then we'll say that there is sufficient evidence to say alternative hypothesis is true, something like that. Okay, now this is the normal guidelines of to use the p-value. So if p-value is greater than 0.1, then we have a weak or no evidence against null hypothesis. If it is lie between 0.05 to 0.1, then we'll have a moderate evidence against S naught. If it lies between 0.01 to 0.05, then we'll have a strong evidence against S naught. And if P is less than or equals to 0.05, then we'll have a very strong evidence against null hypothesis. So let's see an example. Let's say we know the test statistic, or we know the z value. How do you determine the p value? Okay, for this example, this is the value of the test statistic for right tail 1 mean z test is 2.85. Now determine the p value. Now remember, for p value you need to find the area, right? Here it's the right tail test, you need to find the area to the right. So we'll go back to the standard normal table, and the only difference here is previously in critical value approach we use the significance level to find the z-score, but here this is just opposite. We have a z-score, we need to find the corresponding p-value. Now for z equals 2.85, that's your critical value. Now if you go to the standard normal table, I have one here. So for 2.85, so this is 2.8 and then 5 is here. So this is the area. Remember, standard normal table always gives you the area to the left. So this is the area to the left. But for this problem, we need to find the area to the right. How do you find that? Now we know that total area is 1. So using a standard normal table to find the p-value to the p-value to the right, since this is the p-value to the left, so if you subtract that from the total area, which is 1, you will get the required p-value, so 0.0022. So this is how you calculate the p-value. Okay, another example, determine the p-value for 1 mean z-test. Now here the z is given negative 1.19. You need to find the p-value at 5% significance level. So again, just like previous example, find the p-value. This is the left tail test. So for negative 1.19, that's our critical value. For that negative 1.19, you can again go to the standard normal table, negative 1.10, negative 1.11, negative 1.12, and so on. This is the area for negative 1.19. Since the standard normal table gives you the value to the left, so this is the required p-value. Okay, so this is the required p-value. Now since this p-value is less than or equals to alpha, is that true? No, because alpha here is 5%, which means 0.05. If you compare these two values, of course this p 0.11702 is greater than alpha, which means we do not reject the null hypothesis. Remember, to reject null hypothesis, you must have p less than or equals to alpha. But this is just the opposite case, so we do not reject null hypothesis, which means at 5% significance level, the data does not provide sufficient evidence to reject the null hypothesis in favor of alternative hypothesis. Okay, another example. Now this is for right tail test, just like one example I did earlier. So z is 2.85. Again, the process is same. So find the p-value for this critical value 2.85. So for 2.85, if you go to the standard normal table, 2.80, 2.81, 2.82, 2.83, 2.84, 2.85. Now that's the required area. Again, this is the area to the left, but we need to find the area to the right because we're talking about the right tail test. So total area 1 minus area to the left gives you the area to the right. Now this number is very small, and here we are talking about the significance level 1%, which is 0.01. So since p-value 0.0022 is less or equals to 0.01, clearly it's less than 0.01, so we reject null hypothesis, which means we do have sufficient evidence to reject null hypothesis in favor of alternative hypothesis. Okay, let's see another example. This time let's talk about the two-tail test. Okay, now here your z-value is negative 1.71. You need to determine the 5% significance level. Does the data provide sufficient evidence to reject null hypothesis? Okay, just like above example, first find the p-value for this z equals to negative 1.71. Now remember, here we are talking about the two-tail test, so if the one z-value is negative 1.71, the another one is 1.71. So first find the area for negative 1.71. So this is by using the standard normal curve. This is negative 1.70, this is negative 1.71. So that's the area to the left. Now remember, what is the p-value here? Since we are talking about two-tail test, we have two area to the left and area to the right. Because of the symmetric, those two areas are exactly same. So the p-value here is 2 times this number 0.0436, which is 0.0872. Now how do you determine whether you should reject null hypothesis or fail to reject null hypothesis? Well, compare that with the significance level alpha. Now clearly p-value 0.0872 is greater than 0.05 alpha, so we do not reject null hypothesis. So at 5% significance level, the data does not provide sufficient evidence to reject null hypothesis in favor of alternative hypothesis.